Alright, so good morning everyone, and let's get started with our topic Scala. Scala is a programming language. Okay, it is a JVM based language, which means it runs on JVM. Okay, now if you are a Java developer, usually what you do, you basically write a Java program. That Java program gets converted to .class file when you compile it, right? We write a Java code. When we compile that Java code, it gives you a .class file that contains a byte code. Okay, and this byte code would be executed by your JVM. Okay, now when you write a Scala code, it gets compiled to a .class file again, which means a byte code. And JVM, which stands for Java Virtual Machine, right? So JVM understands only one thing, that is a .class file. So it does not matter from where the .class file is coming, it will understand it and it will execute it, which means no matter even if you're writing Java program or you are working with Scala, at the end of the day, you will compile the code, right? And when you compile the code, it eventually produces a .class file, and that .class file would be executed by JVM. Let's take an example. Suppose I live in Hyderabad, and let's say I'm not a Telugu guy, but if I know how to speak Telugu, then probably I can interact with people who speaks Telugu, right? Which means I don't have to be originated from Telugu, right? I need not be a South Indian. If I know how to speak a particular language, that's all enough. So let's take an example of why should you learn Scala today, right? So as I said, the biggest problem with Java is they are verbose, which means you need to write a lot of code just to complete some small task. Okay, they are a little slow from the development time point of view. Okay, and because of that, many people feel it's boring. You need to write a lot of stuff rather than focusing on the main business logic, right? For example, let's say you want to create a class called employee, okay, with some fields, say name and salary, and then you will say, okay, I created a class with a name and salary, but now I need a getter method, I need a setter method, I need a constructor, right? I need a toString method, right? You'll have to either generate it through IDE or you may have to manually type it, whatever, right? But your code looks so big doing the same job. Now, if you want to get into Scala, Scala says you don't have to write all these things. Just tell me that it is a special class by just writing case and I'll take care of the rest, right? Which means Scala says, okay, you are lazy enough, you don't want to write a lot of code, you want to, make your source code compact, and probably you still love JVM, and that's the reason you don't want to move out of JVM. I'm here to help you, right? So that's the advantage you're going to get. Okay, of course, that's not the only advantage, right? So Scala is purely functional programming language. Scala is a pure object-oriented programming language. Let me tell you, Java is an object-oriented programming language, but it is not a pure object-oriented programming language. Why? Because in Java, you have plus, which is an operator, and they are not methods. You have primitive data types like int, okay, float, char, and so on. In Java, you have data types, and these data types are not classes and objects. Because of that, Java is not a pure object-oriented programming language. Okay, it's object-oriented programming language, of course, but not pure. Whereas in case of Scala, this int or float or char, whatever you have, they are all classes. This plus is not an operator, but it's a method. Everything is classes and objects and methods in Scala, okay, which makes it a pure object-oriented programming language. Okay, so now when you want to become a data engineer, there are many languages, right? Out of which there are two languages which are very popular. One is Python and another one is Java and Scala, JVM based language, right? And as I said, It's your choice what you want to learn. There are so many Python based data engineers, they write PySpark code a lot. Okay, but let me be very honest, why should you pick Scala over Python? Okay, number one is JVM, right? When we say JVM, that means the code would work on any environment, no matter what. Okay, there is no doubt at all, right? It follows the concept of write once and run anywhere. You write the code in your Mac, and it does not matter where you want to execute. Just compile it, get this .class file, and this .class file would be understandable by any JVM that's running on any device, right? So the JVM is basically helping us to run the code as it is on every platform, which means you will have no problem of accuracy. Think about this. You have put a lot of effort, build some solution, and then later you realize that it works a little differently on different devices, and that's something that you do not want to do it, right? So that's number one. Second thing, speed. Since the Scala and Java runs on JVM, it performs way much better than Python. You may ask me, then why people are using Python? As I said, a lot of industry build products, a lot of industry works on services. If you're working on services, it's still okay, even if few things runs little slowly. I'll give an example. Our website, onlinelearningcenter.in, is not built on Java. It is built on PHP, Laravel. Why did not I choose Java? Because probably, it would take a little time for me to build. Okay. Second thing could be, I don't need that speed, because how many concurrent user I may have? Maybe 1,000 or maybe 10,000, which I can easily manage. My website would not be used by millions of users anytime, right? So I'm okay with the speed, and that's the reason I chose, okay, it's fine, let's go ahead with the PHP, because the development speed is fast and I don't care about the runtime here. But when you are working on big data problems, the data is already huge. You are required to process billions of transactions or billions of data records every other day, right? And in that process, all that you need is speed. Okay, and as I said, your Java and Scala performs way better than Python. Now ask this question to yourself. If you are here to learn data engineering, you might have heard about a lot of tools like Spark Framework, Hadoop, Hive, HBase, and all. Google it out. You should not be surprised to see that Spark internally is built on Scala. Hadoop is internally written in Java. Hive is internally written in Java. HBase is internally written in Java. Kafka is internally written in Java. Elasticsearch is internally written in Java. Ask this question to yourself. Why did not they choose Python? The reason is because they wanted to build a product, not a service, right? The product should work seamlessly. That's the reason we have decided, okay, let's go ahead with Scala. Okay. And as I said, the advantage of learning Scala is you get a chance to work on writing code for a product. You will build products out of programming language like Java and Scala. There are so many reasons why we prefer Scala over Java. Number one, speed, of course, is very similar. The development speed would be super fast, right? Second thing is, a lot of stuff which were missing in Java is addressed in Scala. And you'll realize that as we move on with the course, once we are done with this 60 hours of program on Scala, everything would look super clear to you. Okay, so I'm just trying to give you little motivation to help you get started on Scala. Why should you learn another language called Scala? And Scala is really in demand. You don't really have to worry about that. There are very few developers who are absolutely good at Scala programming, right? As I said, learning 2-3 hours of Scala might not help you, right? You have to master a language the way you want to. Then only you will be able to, write code independently without taking any help. Okay. So the top three programming language is Java, Scala, and Python. Java is developed by James Gosling in 1995. Scala is built by Martin Ordesky in January 20th, 2004. Python is developed by Gado van Rossum in Feb 1991. Okay, so if you look into the history, what you can actually realize is Python came first, then Java, and then Scala. Okay, which means Scala gives you the advantage of writing short code like a Python, and also gives you a powerful functionality of speed, write once, run anywhere like your Java, right? So that's the greatest benefit that you'll get. Okay, as I said, over the period of time we will explore all the possible benefits of Scala over other programming languages. Okay, now before I start teaching anything, I basically keep a photo of the creator so that you realize the guy, right? So he is Martin Ordesky, who is basically the creator of Scala program. Okay, let's move on. So highlights, the name Scala stands for scalable language. So if you look into Scala, the word is taken by combining scalable language. Okay, the language is so named because it was designed to grow with the demands of its user. You can apply Scala to write wide range of programming tasks, from writing small script to building large system. It runs on standard Java platform and interoperates seamlessly with all the Java libraries, which means suppose you have written a small Scala code, okay, and let's say somebody has already written some library in Java. Can I use that in my Scala program? Of course, yes. Which means Java is so much popular in the market. So many people have, built a lot of libraries. And if you're learning Scala, you still have access to all those libraries. You can directly use it. Okay, that's the beauty, because at the end of the day, both of them are what? JVM based language, right? So you can actually take the benefit of all the tools that was written in Java in your Scala code without any problem. Okay, now there are other programming languages on JVM like Groovy, JRuby, Closure. However, they are not strongly typed language, does not support functional programming, and does not provide any concurrency support. So number one reason for learning Scala is a functional programming language. Now you may say, what do you mean by that? Okay, we'll explore it over the period of time. Don't worry. Okay, so what's wrong with Java? As I said, Java is excellent, robust with rich API support. However, Java is verbose. We end up writing a lot of code for a smaller task. Example, to create a Java bean, you write a class and its property and then its getter methods, setter methods, although you can use editor to produce the code, but still it is lengthy. But as I said, that's not the only reason to not love Java. That's not the only reason to move to Scala. Scala has a lot of other benefits as well, okay? But one of the primary reason that you will see is you're writing a lot of code, okay? Many things are not available out of the box, okay? And what are those things? You will realize when we start understanding the importance of Scala, okay, over the period of time. All right, now look into this. Scala runs on JVM. What does that mean, right? Lengthy Java code, whatever you write, give it to Java compiler. It gives you a .class file which contains a bytecode, and that bytecode give it to JVM, and it produces the output. It gives you the output of whatever you have written. Instead of that, you can still say, okay, let me write a short Scala code, and I have a Scala compiler which will give me a bytecode which would be executed by JVM, and this JVM would give me the output. Now if you look into this whole step, there is only one difference, that is a compiler. So a Java compiler can compile Java program, a Scala compiler can compile a Scala program. Java compiler cannot compile Scala code, Scala compiler cannot compile a Java code because they don't understand each other, right? But once the compiler has given me a .class file, now it does not matter. The JVM can execute the .class file given by anybody. Okay, so let's take one classic example, okay, to understand this again. We'll take some layman example, right? So suppose you went to a restaurant, okay, and you have two options now. One is, hey, I want to have dosa. Hey, I want to have idli. Okay. If you're not Indian, then this is basically an Indian dish for us. Okay. So you went to a restaurant to have this food. Okay. and let's assume this food are not at all ready. Okay, you place your order. You said I need 1 plate of dosa, and your friend needs 1 plate of idli. Now, can you tell me which one would be more faster, guys, to cook? I'm assuming that it is not yet cooked. The materials are ready. The recipes we know, right? The raw materials are ready. Now, which one would be faster to cook? Dosa would be quicker, right? The reason is because you don't have to actually steam it for 10 minutes, 15 minutes, right? Just put a oven and then it will be ready in just 2 minutes, right? Now, whether you consume idli or whether you consume dosa, do you agree with me that you are consuming the same raw material? The only difference is the recipe was different, right? I'll give you another example. Whether you take samosa or whether you take puri, do you agree with me that at the end of the day, you are eating maida, right? Now, take this, consider this your Scala, and consider this your Java. That's the dumbest example I can give you to explain you what is the difference between Scala and Java, right? It's same with some additional benefit, of course, right? What is the additional benefit? For example, as I said, in dosa, you may have little bit of oil or ghee, okay, little bit, right? But then in idli, you will not have that, right? So likewise, Scala comes with its own benefit. It's not just about writing a short code, right? But then it comes with other benefits as well. There are few things which are not even possible in Java that's possible in Scala. What is that? We'll discover that over the period of time. Okay, but hopefully the example serves the purpose for you to understand what is the difference between Scala and Java. As I said, mostly same. The way you write is different, right? Of course, with some added benefits that we'll cover, right? All right. So here is the conclusion. At the end of the day, Java and Scala code are converted to bytecode and then executed by same JVM, right? So it does not matter whether you're writing a Java code or Scala code. When you compile, it gives you a bytecode, and once we have a bytecode, bring any JVM of the world, it will run the code equally. Okay. Now, industry standard. Let's talk about what works in the industry, right? What is the popular combination that you will see? Suppose you are working as a Java developer, right? Now, in that case, you would mostly be writing a Java code, okay? And this Java code would be integrated with Maven. What is Maven? Maven is basically a build tool. You don't have to worry. You'll understand that as we move on, okay? Now, if you are working on Scala project, then it is possible that sometime you'll write a Scala code. It is also possible that sometime you may have to look into the Java code to understand what it does. Okay, and as we move on, I'll show you some of the examples of how the Scala code looks and how the Java code looks so that you understand the connections between them. Okay, so if you're into a Scala project, right? So you would be working on Scala and you might call the Java code. Somebody might have written a Java code, created a jar file out of it, and you might be consuming that Java code. That's fairly possible. And it is also possible that your project is integrated by Maven. Maven is for dependencies. We'll talk about that in the coming days. Okay. Now, it is also possible that you are working on a Scala project and you are dealing with Scala plus Java code, and they are integrated by SBT. SBT stands for a simple build tool, which is much more compact than Maven. In Maven, to add a dependency, you have to write few things. In SBT, to add those dependencies, you will have to write the same thing in a short possible way. Okay, Java versus Scala in nutshell. Okay, number one, as we discussed, pure object oriented. Okay, as I said, while Java is not pure object oriented programming language because of its primitive data type. Okay, so I'm not sure if you know this or not, but Java is a complete object oriented programming language, but not pure. Let me give an example. If you have done your BTech or BE from India, then we all know that you are given 7 years to complete your BTech, right? Now it's a 4 years of degree, but at worst you can complete this in 7 years. And if you go beyond 7, then you will be awarded with a certificate NFTE, not fit for technical education probably. Okay, suppose you have completed BTech in 4 years with no backlogs. Let's call it a pure engineer. Okay, because he has completed BTech in 4 years with no backlogs. Let's say somebody completed the BTech in 4 years, he had some back, okay, and he completed that. Let's call that complete BTech engineer, but the people who have completed BTech without any backlogs, let's call him pure, okay, because they did not get any back in the subject, right? So likewise, when we talk about pure object oriented programming language or complete, right? So as I said, Java is complete, which means it satisfies the minimum condition. What are those minimum conditions? Classes, objects, encapsulations, right? Methods, method overloading, inheritance, right? So Java as a language, it has satisfied the minimum criteria to become a object oriented programming language, and hence it is a complete object oriented programming language. But it is not pure because everything is not classes and objects. Okay, so Scala is completely pure object oriented language as it does not have any primitive type. In Java, you have primitive type like int, float, char, and so on. Whereas in Scala, you don't have primitive types. All these are actually classes and objects in Scala. Okay, so let me take up some questions. SBT, are you referring to Gradle? Gradle is one such tool just like your SBT. It's a brother of SBT. SBT, Gradle, Maven, they are all brother and sisters. Supports both imperative and functional style, which means if you are working on Scala and if you say, hey, I'm an old Java guy and I'm happy to write the code the way it works, you are free to do so. Or if you say, hey, since Scala is a functional programming language, I want to write the same code probably in a functional style. You are free to do that as well. Okay, let's understand using example. So if you don't understand this example, it's absolutely fine because today is day one, right? And in day one, I just want to help you to understand how the Scala works all together. You don't have to worry even if you don't understand this code. This code we will start practicing and eventually will become better over the period of time. Okay. Now, imperative style in Java. Let's assume you are given a list of some numbers. You have a list of integer. The requirement is to find out probably the maximum value out of it. You're given an array or probably a list or whatever, right? And you are supposed to find out the maximum value out of it. What is the best way to do that? Probably you will create a variable, right? And then you'll start comparing that against every number. That's what we were doing. Okay. So the question is, you were given a lot of integers, probably an array of integer or a list of integer, and you are required to find out the maximum out of it, right? So you may say, okay, public int, because I want to find out the maximum number, and that maximum number is basically integer, right? And maybe this is a method name, find max. If you don't understand this, it's fine, okay? And let's say I have a list of numbers. So usually when you give this task to any Java developer, what he will do, he will say, okay, the best way to do would be, I'll say int max value is equal to 0. Let's assume we get a list of numbers and let's say the number is non-zero, for example, okay, assuming that. Now I'll start looping through this number, right? I'll use some loop for intn from numbers. As I said, if you don't understand this, it's absolutely fine. I'm just trying to get you started. Okay, it will iterate for every number, right? Now I'll have some condition like I'll say if n is greater than the max value whatever I had, then I'll say max value is equal to n. So what did I do? I took this number, which is basically a list, started iterating through the list, got access to every element, and comparing that with the previously stored max value. Initially, the max value was 0. Let's say this list has number like 5, 2, 10, 1. Right? And then first time I'll get 5 here. Max value is 0. And I'm saying, is my 5, whatever I got, 5, is it greater than max value? Yes. If that's the case, update your max value to 5. So max value becomes 5. Next time, the number, this n would be 2. Right? Again, I'm checking if this 2 is greater than max value was 5 previously recorded, but now I'm dealing with 2, it's not greater, so skip it. Right? Again, I'll check with 10. Is it greater than max value, which was 5? Yes. So new max value would be 10. Likewise, right? So if you see, you have written a code in a imperative style. That's the old style of writing the code. You may say, I want to do the same thing using functional language. Okay, so let's see how exactly you do that. If you are doing it in Java using imperative style, you will actually do this. But if you say, I want to take the advantage of functional style, then you just write this and your work is done. See here, find max. I got a temperature, which is basically a list of integer. And I'm just saying temperature dot fold left integer dot mean value integer dot math dot max, and it's all done. Okay, behind the scene what happens, we'll discover that. So you don't have to worry if you don't understand what does this fold left method do. Okay, I'm here right now to tell you that, see, the code is so precise. You're done. You don't have to worry about creating a temporary variable. You don't have to worry about looping through the whole loop, right? Many times what happens, when we are looping through the loop, we forget the boundary condition and it does not go till the end, right? That's a common problem we have already faced, right? So when you are doing it in a functional approach, it's only one line of code. It's so compacted, right? So that's how it is. Okay, so as I said, if you don't understand this, it's fine. I just wanted to tell you how short you can actually write the code doing the same stuff, right? And if you're able to achieve the preciseness like your Python, but if it still runs on JVM, then why not do it on Scala? Because it would be much more faster than Python itself. Next, operators are also a function. That's the beautiful concept. Okay, Scala is an object-oriented language in pure form, which means every value is an object and every operation is a method call. For example, when you say 1 plus 2 in Scala, you're actually invoking a method name plus defined in a class integer. So let's talk about that as well. Now listen to me, okay? Suppose you have written a method, say add, okay? So let's say public int int number. Let's say you've written a method add which returns you an integer, which accepts an integer. And let's say this add method is present in a class called math. Okay? If this is the condition, then how do you call this add method, guys? Somewhere in the other side of the code, you create the object of math, right? So you'll say math m is equal to new math. Okay? And then you'll say m dot, I want to call this add method, pass some value 5. So let's say I want to add num1 and num2, 5 and 10. What it will return you back? Some number. Okay, this is how you basically call a method, right? So if you see, this add is a method which takes two value, right? And you're calling it on object, right? Now if you are writing a code in Java, you basically do something like this: 5 plus 10. If you execute this code, it gives you 15 in Java, is not it? Now if you look into this plus, this is basically operator in Java. Okay, but in case of Scala, it is actually a method. So when you say 5 plus 10, what it does, it means 5 dot plus method. Plus is the method name. This is another parameter. Okay, and this 5 is already an object of integer. It's not a data type anymore. It's an object of integer. So if you look into this plus is not an operator anymore. It's a method call in Scala. Okay. And as I said, if you are not well versed with object and classes, don't worry. We will also cover that topic as well, right? So the whole idea of today's session is I want you to get started with the Scala programming. And even if you don't understand couple of coding stuff, it's absolutely fine, because today is day 1. It's not 90, right? We'll be learning this Scala for next 90 days. So over the period of time, you will be much more better than what you are today. Starting is always difficult. Okay, so your add is a function, your plus is a operator in Java, whereas plus is basically a method in Scala programming, right? Which means in Scala you don't have a concept of data types. Everything is a method, right? So Scala is an object-oriented language in pure form. Every value is an object and every operation is a method call. For example, when you say 1 plus 2 in Scala, you are actually invoking a method named plus defined in class integer. Assume the code C is equal to A plus B. In Java, plus is just an operator, whereas in Scala, plus is a method available in an integer class that is evaluated as c is equal to a dot plus of b. You are passing an argument b on a function or method called plus. Next, Scala is static type language. What do you mean by that? Okay, let's understand that. So Java and Scala both are statically typed language, which means when you write the code and before the code is executed, the data type is fixed. Okay, whereas Python is dynamically typed language. So let's understand this. Before the source code is compiled, the type associated with each and every variable must be known. Okay, it means we know its type upfront during compilation itself, and it does not change dynamically in the runtime. For example, check this out. In Java, we write something like this. We write int is equal to b plus c, right? So if I write a code like int is equal to b plus c, that means I'm trying to hold the result in a. So can I say that b plus c probably is integer? Yes, right? Which means before you compile the code, you know it, right? That b and c is actually integer. Is not it? During compilation itself, it will be checked b or c is integer or not. If it is not, then it will throw you a compile time error. Whereas, okay, now see here, let me take you to one example of Python first, okay? In the Python, you basically write a function like this. Define sum x and y, and the function starts and return x plus y. But can you tell me what is the type of x and y here? You don't know, right? It will work with integer, it will work with float, it will work with string as well. You have not defined the type, right? That means it works dynamically based on the type. If it is numbers, then it will do addition. If it is a string, then it will probably do the concatenation. Is not it? So this is actually dangerous. Okay, so your Java and Scala both are statically typed language, which means before you run the code during the compilation itself, you would be 200% sure about a particular operation. Like when you say a plus b is equal to c, when you say c is equal to a plus b, and if you say int c is equal to a plus b, that means a and b must be an integer, right? And you don't really have to worry what will happen at the runtime. Okay, it will be defined before the code actually runs. Okay, now let's talk about Scala. Okay, in Scala we'll write any one of the below. So you may say well a is equal to b plus c, or you may say where a is equal to b plus c. Both of this would work. What the difference will figure it out later. Okay, but that's how you basically define a method. But if you look into this, I'm saying well a is equal to b plus c. So somewhere b is already as defined. You will not just write b plus c. You might say, well, b is equal to 10, right? And you'll also say, well, c is equal to 20. Something like this, right? So when you do that, then you know that b is integer. You know that c is also an integer. And hence, when you say, well, a is equal to b plus c, you are actually adding both the integers, which means you still know what is the data type. So the operators are also a function, right? Which means you really don't have to worry. Everything that you write in Scala is basically a function or classes and objects, right? So that's how it becomes a pure object-oriented programming language. Okay, now we were here, like Scala is statically typed language, right? Which means when you write a code, before it runs, you get to know what is the data type of it. Okay, so for example, take this example. Suppose you have written something like this, well, a is equal to b plus c. Even if you write this, somewhere at the top, you would be writing like this, well, b is equal to 10, well, c is equal to 20, something like this. Okay, when you write this, then you are sure that b is an integer, c is an integer, right? If b and c are integer, then this is perfectly fine, because when you are compiling the code, you know that b is integer, c is also integer, so this is also an integer. You don't have to write int here, but dynamically it understands that it's basically integer only, right? And how does it understand? Because of this previous assignment. Okay, that's the beauty that you get when you are working with Scala. Okay, now strong and infer. So Scala is a strongly typed language, which means data type is checked before performing operations, right? So if you happen to write something like this, well, result is equal to a plus b, Okay, it first checks the data type A and B. Are they both integer? If yes, then this becomes integer. Okay, if any of them is string, then it becomes string, right? So the data types are strongly checked before you are performing any operation, and the result variable would behave accordingly. Okay, but you cannot call it dynamic. It's not dynamic, right? Because before you run the code at the compile time itself, you'll get to know what would be the value of the result, whether it would hold string or whether it would hold integer. Okay, inferred means it is smart enough to understand the resultant data type. So that's the beauty. Like in Java, you specifically write int a is equal to 10. In Scala, you don't have to write int anymore. It's all well and where, but based on the type, it will automatically inject. Okay. Now, Scala can be mixed with Java library, and you can build an entire enterprise solutions based on Scala. Whatever you feel you can do it in Java, the same thing can be done in Scala as well. Let's move to the next. Semicolon and parentheses are optional. That's the beauty. When you start, writing a code, your semicolon is here, this finger, right? And it says, hey, give little rest to your pinky if it is really not required, right? And that's the beauty. When you're writing a code on Scala, your semicolon becomes optional. So here, while writing the Scala code, it is optional to end the statement with semicolon. However, if two different statements are written in the same line, we must use semicolon as a separator. Similarly, based on the context, dot and parenthesis can be optional. How many of you have written this kind of code in Java? You might have written something like this: S1 equals S2, probably within if condition, okay? But in Scala, you can actually ignore this dot, you can actually ignore this parenthesis, and you can actually write it like this as if you're writing English, right? S1 equals S2. It also means S1 dot equals method S2. So if you look into this, can I say this is a Java code where equals is a method, but can I say this is a Scala code where equal is actually a method, but can I say that this equals method I'm using as if it is an operator? Like you used to say a plus b, and what was plus? Plus was an operator in Java, right? But internally in Scala, plus is actually a method, right? So likewise, a method, if you see, looks like I'm using it as an operator. Okay. Operator overloading is allowed. In Java, only plus was overloaded. So if you look into the Java, language, in Java, only plus is an operator which is overloaded. It means it serves two purposes: concatenation and adding the integers, right? But in Scala, you can have your own operator overloaded. For example, if you look into this, even a method, you're able to use it as if it's an operator. Okay? Now, functional programming. So as I said, Java is treated as an object-oriented programming language, but Scala goes extra mile. Scala is a combination of object-oriented and functional programming concept in a statically typed language. As a programmer, you are flexibility to write the code as per your style. Over the period of time, as we move more deeper into Scala, you'll be able to write a code in a functional style as well, right? Now, having said that, as a Scala developer, you have two choices. You are happy with traditional old style, do it. You're happy with functional style, do it. Okay. But I'm sure once you start writing, the functional style coding, you'll find it very boring to write the traditional code. Okay. Example of pure functional programming language. You may ask me, okay, Scala is one such example of pure functional programming language, but do we have any more examples as such? So look into this: Haskell, Mercury, Scala, F Sharp, Java since 8, okay, Schema, SML, Erlang, OCaml. These are all programming languages. There are so many programming languages, right? So all these programming languages are a functional programming language. Okay. So Java 8 also supports functional programming language. Okay. And let me be very honest here. Java started as an object-oriented programming language. Okay. Now at that time, Scala, separated its path and became a functional programming language. Now, slowly, Java is also adopting a lot of features from Scala. Now, look into the hierarchy, look into the story. Java was released earlier. Java came to the market earlier, right? Way back in 1995. and started getting popularity. Python started even before that. Scala saw the opportunity. What is the opportunity? Let me make the code short and precise. Let me make it functional programming. Let me make it faster to develop and execute faster to execute using JVM. And it learned from the mistakes of both these parties, right? And it started something called Scala. Now Java is slowly implementing all the features which are already present in Scala. Okay, and you'll realize that as we talk about the smart features of Scala over the period of time. In Scala, there's a concept called traits. Traits are just like your interface in Java, okay, that can also have methods, and you can actually use these traits, which even solves the diamond problem in your Java, okay. So traits is just like your interface. Don't worry too much. There is a lot of discussion. As I said, today I just wanted to give you highlights of the Scala, okay. Next, easy programming to multi-threading. So if you look into Java, writing a multi-threading code is a nightmare. It's considered as a toughest chapter for any Java learner. Okay, but let me be very honest, multi-threading is required. Why do you need a multi-threading? Think about this. Your whole big data is basically a multi-threaded applications that runs on distributed systems. It's multi-threaded over the distributed systems altogether. So if you want to become a very good data engineer, trust me, you should have a very good understanding on multi-threading as well. Okay, so remember the painful time when learning multi-threading in Java was a nightmare. With Scala, it really does not demand you to concentrate on lock and synchronization. Tough, right? So working with multi-threading in Java is a little tough, okay? But Scala provides you action-based message passing model that can deal with concurrency. Scala has event-based concurrency model. So if you don't understand this, as I said, just skip it up, that's fine. Over the period of time, everything should make sense. Once you are done with the whole Scala code, come back to this day one session and you will be able to recollect the meaning of each and every line, okay? Next, can use Java classes in Scala and vice versa. That's the beauty. You can use Java classes in your Scala program and hence take the advantage of any library that you wish to include in your programming requirement. Vice versa is also possible. Think about this. Java is ruling the market since last 25 years. So many people have come up, written a lot of beautiful APIs, libraries and all. Now all of a sudden, if you're learning Scala, you are not going away from Java. Okay, you can still use all those libraries as if they are written in Scala. That's the beauty, right? Even if it is not written in Scala, you can still assume that it's written in Scala and use it, right? So code which is built on Java can be easily written on Scala, and we'll see that also practically someday. Okay, next. Now Scala does not support below few things. In Java you have a lot of concepts, but what Scala has done is Scala has not included few things from your Scala. Okay, let's see this. Public keyword. There is no public keyword in Scala. Okay, default is public, unlike no access in Java, which means even if you don't write public, by default it is treated as public. Hence, no public keyword. There is no public keyword. Okay, static keyword. Static keyword is also not there in Scala. Instead of that, we have a concept of singleton, and we'll talk about that in the coming days. Okay. Break keyword. There's no keyword called break in Java. Break is used when you want to get out of loop, right? But that keyword is not present. But we have break as a function. Okay. I'm not saying that you cannot break out of the loop. You can break out of the loop, but break keyword is not present. Instead of that, what they gave a break as a function. Throws keyword is also not there in Scala. Throws, if you remember, is used in exception handling when you want to throw a particular exception to the caller. Okay, let's say you want to say, I don't want to catch it, let the caller handle it. That time you use basically throws keyword. So that is not available in Scala, but we have at the rate throws annotation, which means even though they are not present in Scala language, but they are by default available in one or other way.